Hello, I'm Lima Alpha 6, November Charlie Alpha. In this video, I will show the Lichtsprechgerät 8080.
Here on the table, we see two sets of the amazing Lichtsprechgerät 80. This video will cover the technical design and how it is used. The Germans were the only ones to use this technology for military purposes during the war. So what is this? It is actually a light phone. It consists of an optical unit with a transmitting optic and a receiving optic. It also consists of an electronics unit that contains amplifiers for the transmitter and receiver. The lower box contains batteries and accessories. With this equipment, you can talk both ways at a distance of at least 5 kilometers. From the manual, here is a FF33 phone connected to the Lichtsprechgerät. A phone line is also connected. Here is a setup with 2 Lichtsprechgeräts and 1 telephone line. The subscriber on Lichtsprechgerät 80B can now call the telephone network. This example shows that the telephone network can be extended over inaccessible areas using light beams. This figure shows that you can have multiple jumps with light and line. This figure shows an optical relay station. The inaccessible area could be enemy activity or water or something else. Complete setup with telephone and telephone line. Here we see the light source with a red filter. The phone is connected like this. And here is the phone line. Measuring instrument for the 3 voltages used. 2 volts for heating the tubes. 4.8 volts for the light bulb in the optics. 60 volts for the anodes in the amplifier. The filter with red, white, and infrared. First, let's take a closer look at the optical unit. Here we see the optical detector. It can be easily replaced in case of problems. A lid that protects against mechanical and electrical interference. A rotating filter in the transmitting optics. White, red, and infrared light. This is the light source. A 5-watt light bulb. A special bulb that has a machined metal holder for precise placement of the filament. Absolutely incredible accuracy. Here's another lid. These are the receiver's preamplifier tubes. A wonderfully solid design. The glass tube is in a rubber suspension inside an aluminum tube. This is a knob for adjusting the modulator. A very solid mechanical attachment for the tripod. You can precisely adjust the height and side settings. Here is the connector for connecting the electronics unit, power, audio to the transmitter, and audio from the receiver. We see 3 lenses. The small one in the middle is the scope used to find the direction to the other station. Now I will go through all the functions of the optical unit. Here we see the function of the receiver. An 80mm lens collects the light at a point approximately 210mm from the lens. This is quite simple. The photocell is placed exactly at the focal point of the lens. Just connect an amplifier to the photocell, and everything works. The photocell's amplifier tube is placed right next to the photocell to avoid noise. The attachment to the photocell is very precise. It is made of porcelain. The photocell is made of thallium sulfide. None of the cells work anymore, so it needs to be replaced with a modern photodiode. A BPW34 photodiode fits perfectly. Here, we look through the lens. We see the photodiode in the hole in the porcelain. The transmitter is incredibly complicated. A 4-watt light bulb is placed in a chamber 1. A reflector, 2, helps to direct the light to the right in the drawing. A lens, 3, collects the light in an optimal way before it leaves the light chamber. Here is the chamber and the lens. The lens can be adjusted with the screws. This small light beam reaches 5 kilometers. The light bulb holder has been removed from the light chamber. There are 2 different bulbs, 2.4 volt and 4.8 volt. 2.4 volt has a yellow ring. All equipment is marked with a yellow ring when operating at 2.4 volts. Then the light reaches the modulator, 4. This AM modulates the light. The modulator is completely unique. The light enters the prism at point A. The light is first reflected in B, and then E, and then exits through the lens, F. The light is reflected 100% at point E. It does not at point B. Here, the angle of the light is such that it is on the verge of escaping the prism. Here, a smaller prism is placed in the critical area. This is applied with a constant force against the larger prism. Electromagnets, G, controlled by the amplifier, change the pressure against the larger prism. This allows the light to be AM modulated. The degree of reflection depends on the pressure. This is optically very advanced technology. Here we see the amazing advanced modulator. Here we see the prism where the light enters at the top and where it exits at the bottom. Here we also see the small prism that is affected by the electromagnets. This is the adjustment of the pressure between the prisms. This is adjusted before use to maximum modulation. The red ones are the coils of the modulator. Here we look into the prism. Modulator prism. Impressive accuracy in the mechanics. The light leaves the prism and passes through the filter, 12. The filter is located in the light beam after the prism. It has 4 positions. There is white, red, and infrared. There is also one with a lens. The light then passes through the lens, 7, and out to the receiver far away. The light is now completely parallel, so that the beam is only a few meters at a distance of 5 kilometers. I have turned on the light. This is all the light. It's incredible that this reaches over 5 kilometers. It's impossible to detect if you're outside the beam. Dims the light in the room. Here we see white light, red light, IR light, extra lens inserted. The light beam is extremely small, so it is important that it hits the receiver. Therefore, there is a very good telescope mounted in the optical unit. This is placed between the transmitter and the receiver. The focus is set in the lens, 8. This is the aiming telescope. It also has a mechanical sight. Seen through the sight, Follahavna Fort, 2.5 kilometers away. How can you aim a beam of light that is only a few meters at a target that is many kilometers away? The optics, 9, extracts an optical image of the filament in the light bulb and presents it into the image of the aiming scope. The operator will see a picture of the filament on top of the picture of the target. This is a prism and light guide that captures the image from the transmitter and presents it into the aiming scope. The brightness can be adjusted. Here we see the prism. It has 2 positions, T and N. It gives 2 different brightnesses. Amazing accuracy when it transfers the image from the transmitting optic to the aiming optic. Here we see the red dot at almost 5-kilometer distance. It is easy to find the right direction of the optical unit. Here we see the red image of the filament in the sight picture. The white light down to the right is the light beam itself. Modulator monitor. For the modulator to function optimally, the pressure between the large and small prisms must be adjusted to the optimal pressure. It is done like this. Here we see the small prism. It is mounted on a piece of steel that is manipulated by 4 electromagnets. Here we see it from the inside. Adjust to max signal out. The modulation can be read in the green light. The green light comes from the back of the small prism. It is the light that escapes and is the bottom of the sound curve. The top come out towards the target. Light guides that collect the light from the prism and put it into the aiming scope. Tests with light. The light guides are green. See the little green dot at the top. This is the modulator monitor with the green screen at the bottom. A light guide supplies light to the small red lamp and to illuminate the modulator button. We'll take a look at the electronics. The electronics are placed in a separate box. The lower part consists of the equipment box and batteries. The upper part contains the electronics and some spare parts. A thick 6-conductor multi-cable connects the electronics to the optical unit. This is where you connect power, headset, microphone, telephone line, and telephone. Behind the cover, we find the tubes. The German equipment is very easy to maintain. You just pull out and replace the critical components. All the tubes are the same. This makes the supply of spare parts easier. The RV2 P800 was developed in 1936 for use in the Army. Germany was rearming heavily at the time. Much of the communications equipment was designed around this tube. We will now see what the electronics device looks like inside. Wow. Look at the beautiful tube sockets. Look at how the cables are tied together and the order in which they are mounted. Look at how the passive components are mounted. Each component has its number printed on it. Each node is also labeled. This has been done to make maintenance easier. I never get tired of working with these tubes. Amazing precision can be felt when you pull out the tube. Each tube is marked with the year and month of production. Maintenance was important. Electrical schematic is mounted in the lid. The electrical schematic. Here we see the node numbers printed on the soldering points. We also see the component numbers, both in the drawing and the component list. Redrawing of the electrical diagram. Lichtsprechgerät in US. Photo of the German military practicing communication with light. Perhaps you would like to comment below more about these. Another picture of its use during the war. From Ohama Beach in Normandy. The Lichtsprechgerät was used for communication from the beach to the command bunker 1,500 meters away. HKB Vesteruen Fort in Sandefjord had an observation post and searchlights in Kjerringvik. A separate bunker was built for this. And here is the original table that matches the Lichtsprechgerät. Here we can see the fort in the distance. Here I am testing the communication over almost 5 kilometers, from the town of Larvik to the town of Stavern. I have found a nice old German fort down by the fjord. I'm installing the equipment. Now everything is ready here. Clear view towards Stavern. At the same time in Stavern. LA4ZRA is getting the equipment ready here. He aims his optics and tries to find our light. We can see the town of Larvik far in the distance. We will now show the testing at a distance of 5 kilometers. Turn on the subtitles for your language, because everything is in Norwegian.
Sånn. Jeg måtte få det med på radio. Ok da, Egil, kan du høre meg nå? Nå har vi startet filmingen.
Ja, jeg hører deg kjempebra.
Ja, men nå kan jeg også se lyset ditt fint.
Ja, jeg også ser lyset ditt.
Kan du telle til 20?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Ja, nå er det jo perfekt her. Hvordan hører du meg nå?
Ja, nå ble du svakere hos meg.
Ja, da skal jeg telle litt fram til, så skal du si fra om det blir bedre. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Ja, nå er det bra, ja.
Nå er det fint?
Ja, nå er det fint.
Ja. Da er dette vellykket. Kan du forklare hvor du står igjen?
Ja, nå står vi på Risøya utenfor Stavern.
Ja.
Da pakker vi ned.
Ja, det er mottatt. Da ble det vellykket allikevel, etter masse arbeid.
Kjempebra.
Ja, takk for jobben.
Ja, takk.
There is impressive technology in this optical equipment. The modulator is unique, and I have not seen anything like it anywhere else. It is absolutely incredible that the small light that is barely visible can reach 5 kilometers. The receiver is also incredibly good. The light can hardly be seen with strong binoculars, and only when you are inside the beam. Therefore, this can be used for secret communication. Israel used it for secret communication after the war. It was the only communication that could not be intercepted by its enemies. Thanks to LA4ZRA and LA1GIA. Please leave a comment below the video and press the like button if you liked it. Thank you for watching my video.